In this session, we are doing problems on basic inverse Laplace transforms. These are the formulas from basic inverse Laplace transforms. The first problem is find L inverse of 2 by s plus 1 by s cube plus 1 by s power 4. Find L inverse of this one. L satisfies linear property, so L inverse also satisfies linear property. Here we have two operators, L for Laplace transform operator, L inverse is inverse Laplace transform operator. Whatever we studied in the previous sessions on properties of Laplace transforms, the same going to be hold for L inverse also. So as L satisfies linear property, L inverse also satisfies linear property. So that we will get linear property means L inverse we will get to each and every term. So it is equal to L inverse of 2 by s plus L inverse of 1 by s cube plus L inverse of 1 by s power 4. L inverse does not affect the constant like that of L. So 2 into L inverse of 1 by s plus L inverse of 1 by s cube plus L inverse of 1 by s power 4. It is equal to, we know inverse Laplace transform formulas. Here if you observe, L inverse 1 by s equal to 1. Already we know L of 1 equal to 1 by s. So L inverse of 1 by s means 1. So 2 into 1 plus here we are observing highest power of s, that is s cube s power 4. We will get highest powers of s in the formula L inverse of 1 by s power n plus 1. We will get in Laplace transform of t power n. Try to remember like that. L of t power n equal to n factorial by s power n plus 1. Only in this Laplace transform we are seeing highest powers of s. So L inverse 1 by s power n plus 1 means t power n by n factorial. This formula. So according to this, 1 by s cube we are observing, that is s cube we will get in t square Laplace transform. So t square by 2 factorial plus s power 4 we will get in t cube. So t cube by 3 factorial. So it is equal to 2 plus t square by 2 plus t cube by 6. So if you keep indirectly the formulas of Laplace transforms in mind, easy to evaluate inverse Laplace transforms. The next problem is find L inverse of 3s plus 4 by s square plus 16. Find L inverse of 3s plus 4 s square plus 16. Here in the denominator we are observing s square plus a square. We will get s square plus a square in the Laplace transforms of sin at cos at. So we know Laplace transform of sin at equal to a by s square plus a square, and Laplace transform of cos at equal to s by s square plus a square. Means we are going to get sine or cos functions in evaluating this inverse Laplace transform. But in the denominator we are observing 3s plus 4. But here a and s means able to split this as 3s by s square plus 16. 3s by denominator plus 4 by s square plus 16. Now we know inverse operator satisfies linear property. So L inverse of 3s by s square plus 16 can be written as 4 square plus L inverse of 4 by s square plus 4 square. So L inverse L inverse we will get both the terms. That is called linear property. Now here for cos AT Laplace transform is s by s square plus a square. Clearly s by s square plus a square in place of a 4. Here a by s square plus a square. This is the Laplace transform of sin AT. But here 3 extra. From the linear property, operator doesn't affect the constant. So we have chance to write down outside of operator. L inverse of s by s square plus 4 square plus L inverse of 4 by s square plus 4 square. Now clearly s by s square plus a square, that is the Laplace transform of cos AT, and a by s square plus a square is the Laplace transform of sin AT. So 3 into L inverse, if you shift this side, L inverse of s by this one becomes cos AT in place of a4 cos 4t plus a by s square plus a square, that is for sin AT Laplace transform. So it becomes sin 4t. So the next problem is find L inverse of 1 by 4s minus 5. Find L inverse of 1 by 4s minus 5. So here we are observing s minus a, but here coefficient of s is extra. So try to remove that one. So L inverse of, if we take 4 common here, s minus 5 by 4. So from linear property you may write down 1 by 4 outside of L inverse. So 1 by 4 into L inverse of 1 by s minus 5 by 4. Clearly we know Laplace transform of e power at we will get as 1 by s minus a. Clearly s minus a. So it is equal to 1 by 4. 1 by s minus a in place of a 5 by 4 in L of e power at. So this is inverse Laplace transform of e power at. Here a means 5 by 4. So always while doing problems from inverse Laplace transforms, under L inverse what is the function present and which is it is the linear Laplace transform of which one, which function. We need to understand like that. So here 1 by s minus a, this is the Laplace transform of e power at. Here a by s square plus a square, this is the Laplace transform of sin at. Like that we have to think so that we will get easily the problems. The next problem is find L inverse of 1 by s minus 2 whole square. Here we are observing s square, but in place of s, s minus 2. So s changes to s minus 2 because of exponential function. And here s square, if you see s minus 2 if as s square, we will get highest powers of s in the Laplace transform of t power n. We know L of t power n equal to n factorial by s power n plus 1. And L of e power at t power n equal to n factorial by s power n plus 1, but s changes to s minus a because of this exponential. Means here s square we will get in Laplace transform of t, and s changes to s minus 2. S changes to s minus 2 because of e power at, because of e power 2t. Clearly we know L of t here in place of n1, that is 1 by s square. Clearly 1 by s square. So in Laplace transform of t we got s square, and s changes to s minus 2 because of e power 2t. So within one step we got. And the next problem is find L inverse of 1 by s plus 4 whole cube. And here also we are observing highest power of s. That means clearly we know L of t square equal to 2 factorial by s cube. But here 2 factorial not present. So try to insert 2 factorial by s plus 4 whole cube. Because of this 2 factorial, write down here also 1 by 2 factorial, so that both will be cancelled. Equivalent expression. So 2 factorial by s cube we got, that is it is the Laplace transform of t square, but s changes to s plus 4, that is because of e power minus 4t. 1 by 2 factorial. So always we have to observe the function under L inverse is the Laplace transform of which function. So 1 by some s highest power of s we are observing. This we will get 1 by s cube we will get in the Laplace transform of t square. So okay, the going to be in terms of t square, but in L of t square 2 factorial is there, that is missed here. That's why try to insert 2 factorial. So in order to equate, divide with 2 factorial. We got the required expression, but in place of s plus 4. So s changes to s plus 4 because of the exponential. The next problem is find L inverse of 3s plus 5 root 2 by s square plus 8. To find this inverse Laplace transform, first linear property L inverse of 3s by s square plus 8 plus L inverse of 5 root 2 by s square plus 8. Now you may write down 3 outside of L inverse. So 3 into L inverse of s by s square plus a square. But how to write down 8 as a perfect square? That is 2 root 2 whole square. So s by s square plus a square. This is the Laplace transform to cos at. Okay. Next. Here L inverse of 5 root 2 by s square plus 8 means 2 root 2 whole square. Here we are observing constant by s square plus a square. But sin at Laplace transform is a by s square plus a square. Sin at Laplace transform is a by s square plus a square. Here a is 2 root 2. That's why we require here 2 root 2. But here 5 root 2 present. Write down 5 outside and we include 2 here. That's why write down divided by 2. 2 cancel. We have the resulting is same 5 root 2. So in order to get sin at Laplace transform, we are inserting 2 here in multiplication and the division. Now 3 into, if you observe under L inverse the expression is s by s square plus a square. This is the Laplace transform to cos of 2 root 2 t plus 5 by 2 and a by s square plus a square. Whatever here present, try to obtain in the numerator. This is Laplace transform of sin 2 root 2 t. Next problem is find L inverse of s by s plus 3 whole square plus 4. Here also L inverse of s by s plus 3 whole square plus 2 square. Clearly in the denominator we are observing s square plus a square, but s changes to here s plus 3. That is because of e power minus 3t. But here in this s we won't have s plus 3. So in the numerator try to obtain s plus 3. So in order to get s plus 3, L inverse of add 3 and subtract 3. So that we will get like this. So now apply linear property on this one. Write down s plus 3 up to one term minus 3 second term. So you will get L inverse of s plus 3 by s plus 3 whole square plus 2 square. Next minus 3 into L inverse of 1 by s plus 3 whole square plus 2 square. So that you will get s by, treat the whole as s by s square plus a square, and s changes to s plus 3. S by s square plus a square is Laplace transform of cos 2t. In particular a2, s changes to s plus 3, that is because of e power minus 3t. Minus 3 into, here 1 by, treat this as s, 1 by s square plus a square. And here a is 2, constant by, that is this is sin at Laplace transform, but in place of a we have 2, we require 2 here, that's why multiply with 2 and divide with 2. So minus 3 by 2. Now clearly are observing 2 by s square plus 2 square. This is sin 2t Laplace transform, but s changes to s plus 3, that is because of e power minus 3t. Like that we try to understand the formulas of Laplace transform to evaluate inverse Laplace transform. This is possible if you know clearly the Laplace transform formulas as well as properties of Laplace transforms in mind. After this, the next problem is find L inverse of s plus 3 by s square minus 10s plus 29. In the denominator, we are observing s square minus 10s plus 29. It is not a perfect square. Try to write down this as a perfect square. So L inverse of s plus 3 by, how to write down this, a square minus 2ab, that is minus 2 into 5 into s able to write down. So that you will get s minus 5 whole square. S minus 5 whole square means s square plus 25 minus 10s. In s minus 5 whole square we will get minus 10s. So if we write down like this, but here s square minus 10s plus 29 present, but here we used only plus 25, that's why I write down plus 4, so that both will be equivalent. Plus 4, so that s minus 5 whole square plus 4. Now it is s square plus a square. S square, if you treat this as s square plus 2 square. Okay, the problem going to leads to either sin at, cos at, Laplace transforms. S changes to s minus 5, but here s plus 3. So try to write down it as s minus 5. If you write down s minus 5, but here s plus 3, you have to write plus 8 here, so that it becomes s plus 3 by s minus 5 whole square plus 4. Now it can be written as L inverse of s minus 5 by, keep up to one term, s minus 5 whole square plus 2 square plus 8 by s minus 5 whole square plus 2 square. Now by linear property L inverse of s minus 5, linear property means we will get L inverse to both the terms. So s minus 5 whole square plus 2 square plus 8 into L inverse of 1 by s minus 5 whole square plus 2 square. If you observe this one, okay, see s minus 5 as s. So s by s square plus a square. This is Laplace transform of cos 2t, and s changes to s minus 5. This is because of e power 5t. Plus 8 into, this is a by s square plus a square, but in place of a we have 2, but 2 not present here, so into 2 divided by 2, cancel the equivalent expression. So we are observing 2 by s square observe this as s, 2 by s square plus 2 square. This is sin 2t Laplace transform, and s changes to s minus 5. That is because of e power 5t. So like this we have to evaluate inverse Laplace transforms. And note down some more problems. That is, find L inverse of 1 by s square plus 2s plus 5. L inverse of s plus 2 by s square minus 4s plus 13. Find L inverse of s plus 1 by s square plus s plus 1. And find L inverse of s square minus 3s plus 4 by s cube. Do these 4 problems on your own. These 3 are like that of this problem, means try to write down it as a perfect squares and try to express in terms of sine or cos Laplace transform. And to this problem, here able to write down this, able to split this expression as 3 more terms, s square by s cube minus 3 into s by s cube plus 4 by s cube. It turns to L of t power n. This formula involves L of t power n. So finish these 4 problems. With this, problems on basic inverse Laplace transforms over.